guys, today we're doing deductive reasoning. So if you remember the first day with our logic puzzles, that was all about inductive reasoning, using patterns. All right, deductive reasoning, all right, it's a little bit different. So we're going to skip this front part here. We might do that in class of you writing those equations or those sentences. Big thing here, deductive reasoning, okay? It uses facts, all right? And it goes from general information to very specific. It's kind of like detective work. So you're going to start with a big pool of suspects. You're going to get rid of a lot of that, like the red herrings and the things that actually aren't the suspects, and kind of bring it down to that one thing there. So we're going to have a lot of information to start off with, and we're going to cross things out and kind of focus on the two things that we need to see. So we have two different things we're learning today, the law of detachment and the law of syllogism. All right, the first one, the law of detachment. It says, if P, then Q is a true statement, and P is Q, if P is true, then Q is true. None of this really makes sense to me, guys, so ignore that. All right, I'm going to focus on an actual example. So it says, here's our rule. It says, if you win the lottery, then you are wealthy. And I'm going to tell you that your friend Sally won the lottery. So what conclusion do you think we can make if this original one up here is our rule? Now our rule says if you win the lottery, then you are wealthy. If Sally just won the lottery, what can we assume? We can now assume that Sally is wealthy. Let's do some more examples. It says, if it is snowing, then it is below 32 degrees outside. That's our rule. I'm telling you today that it is snowing. So can we conclude that it is below 32 degrees out? Yeah, that was the rule. If it's snowing, it has to be below 32. And I told you it was snowing, so yes, that would be valid. All right, this one says, if you drive a school bus, then you stop at railroad crossings. I am telling you that Otis stopped at a railroad crossing. Can we assume he was driving a bus? Now you'll notice here, it says if you drive a school bus, so that's what I have to tell you first. Did I tell you that you were on a school bus to start off with? No, I told you that you were stopped at a railroad crossing. We can't work backwards in that if-then statement. So this would be invalid because I didn't tell you that if first. An example could be he could just be stopped because he's in a car or he's in a truck and there's a train going by. All right, would be like a counter example. Number 3, all right, it says if two angles are a linear pair, then they have a sum of 180. Okay, so if they're a linear pair, then they equal 180. I'm telling you that A and B are supplementary. Can we assume they're a linear pair? So let's think, is this statement I just told you, is that the if statement that I told you beforehand? No. Okay, so can we then assume that they're a linear pair? No, this would be invalid. All right. Up next says, if x plus 3 equals 5, then x equals 2. Fair enough. Now this one's a little bit different here. It says x does not equal 2. Okay, so x does not equal 2. If x does not equal 2, is this statement then going to be true? So let's think, if x isn't 2, so if x is 3, if I plug in 3 here, 3 plus 3, does that not equal 5? Yeah, that's true. So this would be a valid one. The reason why this one works is because I made both of these statements negative. Okay, whereas the other ones weren't negative at all. Okay. All right, the next idea is this thing called the law of syllogism. I call it syllogism. Some people call it something else. If you just try to say law of I will understand what you're talking about. So law of syllogism. I ignore the stuff up here because this doesn't make sense to me. Okay, we're going to do an example. This is when you go from two if-then statements to a single if-then statement. So we're kind of going to condense down the repeat stuff is what I say. So this one says, if a number ends in 0, then it is divisible by 10. If a number is divisible by 10, then it is divisible by 5. So here's what I do is I'm looking at that. I'm going to condense it down to one if-then statement. How I do that is I get rid of what they repeat twice. So if you look at that sentence, what statement do they say twice? They say divisible by 10 twice, so we're going to get rid of that. And what's left is our if-then statement. It says if a number ends in 0, comma, then it is divisible by 5. So I cross out that repeat. Because if the first then is true and the first if is true, you can combine them into one. All right, we're going to do the same thing here. So it says, if the measurement of angle A is less than 90, then it is acute. If angle A is acute, then it is not a right triangle. So I want you to kind of ignore that conclusion right now. Just look at that given. Is there anything they repeat twice? You're right, they repeat angle A is acute. And what is left over is, if the measurement of angle A is 90, then it is not a right triangle. And that's the same exact conclusion we made there. So this would be a valid conclusion. Okay? And that could be any other angle in that right triangle, could be right, right? You're going to have two acute angles within a right triangle. All right, number 5. If the food is terrible, then Ernie is upset. If Bert cooks food, then the food is terrible. All right, so what do we repeat twice here? I think we repeat the food is terrible. So I'm going to cross that out. Food is terrible. Food is terrible. What I have left over is, if Bert cooks dinner, then Ernie is upset. Is that the same conclusion they made on your paper? No, they said if Ernie is upset, then the food is terrible. So this is an invalid conclusion. Reason being, Ernie could be upset for many other reasons. Okay, so if Bert cooks dinner, then Ernie's, that would be the correct thing to conclude there. What I want you to pause this video and try number 6 and 7 on your own. Okay? Hopefully you tried them on your own. You're coming back and trying this. So we're saying, if you are a jabber, then you gibber. If you gibber, then you laugh. So when I look at this, I said that you gibber is repeated twice. So my conclusion was, if you are a jabber, comma, then you laugh. I know it doesn't make sense there. I'm making up words with gibber and jabber. That's a perfect sentence. This one's a little bit crazier, a lot more sentences here. It says, if a team wins 10 games, then they play in the finals. If a team plays in the finals, then they travel to Boston. And they told you that our team actually won 10 games. So I'm looking, this is part of our conclusion. If our team won 10 games, so that's part of our conclusion down here. So if it says, if a team wins 10 games, then they play in the finals. If they play in the finals, then they travel to Boston. I think they say play in the finals twice. So it says, if a team wins 10 games, which we were told our team does, then we're traveling to Boston. Going to Boston.